Alright, let's have a look into the 4 key components of an Android application. I mean, half of the vulnerability relies in the network traffic regarding to HTTPS or other TCP connections, and the other half is within those 4 components. So let's start with activities. And now's the question, what is an activity? If we start our application, so if we click on the icon on our smartphone, like this one, then a screen appears on our screen, and like this one. The screen is now showing some username, some password and login. This screen is an activity. So this is some kind of screen content. In our case, it's a logging activity. If we now perform our login, so if we enter the correct credentials and click login, then another screen appears. In this case, it's profile. Profile, once again, is another activity. So it's another screen content. If we now click the button settings, then another activity starts, which is absolutely correct, the settings activity. So settings, or the settings activity, is just another screen content. And last but not least, we've got this code button, which starts our last activity, which is the code activity in our application over here. All right. Okay, so here we have now all of our activities, but it hasn't to be in one way. For example, the code activity could also launch other activities which has been seen before. In this case, it's the profile activity. So if we click within the code activity, the profile button, then the profile screen appears, which is simply just the profile activity. All right. So it hasn't to be in one way. We can also interact between those activities. All right. To sum this up right now, activities are simply just screens. That's what an activity is. So we've got a screen layout structured in an XML. And yeah, this structure is being opened when we open such an activity. So we simply just open another screen. Opening certain screens can be dangerous. I mean, they have been protected by a username and a password. For example, to opening the profile or the settings activity, we need to insert those credentials to get into this application. Of course, yes, this is why we have this password protection. And therefore, we've got the square around all of them, which means those activities are within or are protected by the application context, which means only the current user, the user ID, which we have seen in those permissions, or some really high system applications can interact with this one. For example, if we have root, yes, we can simply start whatever we like, but another malicious application like this one over here cannot access them. So we can start the logging activity with our malicious application. Yes, that's correct, because that's the activity that has been defined as the launcher activity, but all other activities are being protected. So we cannot simply access them, which would be a huge security risk, of course. All right, so now this question, where's the problem, right? So everything looks fine. We've got a username and a password. We need to enter them to enter the other activities or to enter the context of this application. So everything is fine, right? Yes, until we've gotten a certain case. And this case could be the following. Let's assume our code activity is something like a QR code or some other secret code, which can be scanned by a camera application, like this one over here. So if this camera application now scans in secret code and we want to open our application, this is not working right now, because if this camera scans this code, it tries to open this activity, but this has been protected with the application context. So the camera application cannot simply launch this activity right now, and therefore it doesn't open, and yeah, our app wouldn't work. Now as a developer, we've got this use case. I mean, we've gotten secret code and we want to scan this with a camera application, and then we want to open our app. So that's an absolute valid use case, right? Absolutely. And therefore we've got a solution for this one. And the solution is exported. So we can export certain activities, which means they are now reachable from the outside world, which means this camera application can now start this activity. But only this activity, not the other one. For example, those profile or settings, because this would be dangerous right now. The way it's working right now is based on intents, and we will have a look into intents in the next couple of videos. So that's a pretty amazing system. Alright, but so far I would suggest everything looks good at a first view. I mean, we can interact with our application by scanning in secret code, and the other ones are still being protected. For example, we can only reach the settings activity, which can change our password, if we log into this application, click on the settings button in the profile activity, and then we can interact with this one, right? Unfortunately not, because in the code activity there was something. Wasn't there a certain button? Oh yes, within the code activity, we are able to start the profile activity. And this is how those vulnerabilities can be created as a developer right now. So we've gotten certain use case. We want to start this code activity, which is absolutely, it's valid fine. But we have to think this to the end. If this activity can also start other activities, or for example, the profile activity, then we're having a huge problem right now. The profile activity is within the secure application context. Yes, this activity has not been exported to the outside world. Yes, but once we have reached this internal security context via the code activity, and if we have the ability to start this within our code activity, then we can once again interact with everything else in the secure context, which means we can start this profile activity from this code activity which has been exported to the outside world. And this means we can also start the settings activity, because once we have reached this internal context, we are within this user context of this application. So we have the permissions or the rights to interact with all the other components in there, which means if those activities are interconnected, then we can also start other activities from one which has been exported to the outside world. All right? Yes, this sounds now a little bit confusing, but don't worry, we will do some exercises regarding to this one and then it will be crystal clear. Alright, how we can exploit this right now. The exploitation could be done, for example, via malicious application. We can use a malicious application to start the code activity. Once we have started the code activity, because this one has been exported, we can reach the profile activity and then jump to the settings activity, and we could, for example, change the user password. Sometimes these approaches works and sometimes they don't. The reason why they are not working could be the following. Let's say our user credentials are being encrypted, and if we log in into this application, those user credentials will be decrypted. Now, if you're using some functionalities, the application assumes that everything has been decrypted, because this is the case when we log in into this application. If we now try to interact with certain things, for example, a password change or things like this, the application could crash because we have cheated a little bit. Okay, we have cheated a lot to get to a certain state, and this application might have to set up certain states before. So it doesn't mean just if we can launch an password change activity that this one functions correctly. This is something we have to verify. Nevertheless, if we can interact with all those activities, there's at least one function that could cause trouble in an application, most of the time. Okay? So this is something we need to look for. Now's the question, how can we identify this vulnerability? So where do we have to search to get this information if an activity has been exported or not? And the answer for this is in the Android manifest XML. So this configuration file has all these information about our activities. Or otherwise, if we are creating an activity, there will be an entry for this activity in the Android manifest XML. Okay, so now we know where to look for. But what is the term we need to look for? Well, there are two options. We've got explicit exported and implicit exported. Explicit exported, super easy, because we simply got this tag exported equal true. If we find this in our application tag, then we know this activity has been exported. All right. The other one is implicit exported, and we have already seen this. Implicit exported simply means everything that has an intent filter is automatically being exported to true. So this is something that might not be that obviously right now, but that's the case. So if we know this, then we are good to go. These are the only things we need to look for if we want to know if an activity or another component has been set exported to true or not. We have already seen this intent filter in our Android manifest XML in the launching activity, and now we can get our puzzle together. The launching activity has this intent filter, which means the launching activity is being set to exported true. So this activity is available from the outside world. And of course, it has to be if we think about this. So let's say our activities are within a secure application context. If we click on an app icon, we need to start at least one activity, the launching activity. Therefore, this activity needs to be reachable from the outside world. Otherwise, we couldn't even start our application, because even the system service, which is starting those activities, has not the permission to interact in the secure context, of course. Otherwise, this would be absolutely dangerous, because this service could also start a profile or a settings activity in this case right now. So how this system is working, I mean, it's pretty amazing. We've got an activity, the launching activity, and this one is being exported to the outside world. which means every application could start each other. So we could make a malicious app which is constantly starting other apps, but that's not a real use case, right? It's super annoying, but it's not dangerous, just annoying. Okay, back to this one over here. So now we've got our secure context and we've got one activity, the launching activity, which is being exported to the outside world. Once we have started this activity, we can also interact with the other components. So we are then within a secure context and we can, for example, launch or open the profile activity if we have provided the correct credentials. So this is how this whole system works, and this is the reason why we're having always this intent filter with our launching activity. All right? Okay, in our case right now, if we want to export this code activity, we can simply use exported equals true, and then this is available from the outside world and can be started via a camera application or something else. Alrighty? Okay. So now I have already spoiled it, but this whole exported scheme doesn't only affect activities. It affects all of our key components, which means also broadcast receivers, services, and content providers. And we have to look into every single component to search if there are some vulnerabilities regarding to this one. Okay, so for now it was a lot of theory, and therefore I would suggest in the next video we will have a look into a practical example, how to identify those exported activities and how to interact with them. How can we start another screen content and also searching for some kind of vulnerabilities inside there. Alrighty? Okay, I'm looking forward to see you in the practical part.